Hi, this is problem 17 from the AMC 10A and problem 13 from the 12A. So let n be a positive multiple of 5. One red ball and n green balls are arranged in a line in random order. P sub n be the probability that at least 3/5 of the green balls are on the same side of the red ball. Observe that P5 is equal to 1 and that Pn approaches 4/5 as n grows large. What is the sum of the digits of the least value of n such that Pn is less than 321 over 400? So I found this problem rather hard, and it's difficult because it's hard to keep all this information straight. And when I'm faced with that, what I like to do is look at case examples and try to make a few figures to try to sort this out. So let's go ahead and do that. Let's look at the smallest value of n. N is equal to 5. So this threshold value, 3/5 n, is equal to 3. And we have 6 balls in total. And the condition that the green balls are to the left specifies that the red ball has to be over here, and that the green balls, 3 green balls are to the right, specifies that the red ball has to be over here. And so we can calculate the probability now as the shaded region is 6 minus 3 multiplied by 2 divided by the total number of balls, and that's equal to 1. And that checks out, so that looks encouraging. Let's try another case. N is equal to 10, so the threshold value is equal to 6. We have 11 balls in total. Let's draw those out. And so the threshold condition for the 6 green balls to the left makes the red ball appear in these last 5 slots, and for the 6 balls to the right means that the red ball has to be in one of these locations. And here again we can write the probability as the shaded region, 11 minus 6 multiplied by 2 divided by the total number of balls. That's 10 over 11. And that's kind of going in the right direction, so I think we're on the right track here. Let's try one more. Okay, so we have 16 balls. It's getting a little crowded. And let's see, so for the 9 green balls to the left, specifies these locations for the red ball. The 9 green balls to the right specifies this location for the red ball. And the probability now is 16 minus 9 times 2 over 16, and I don't know what that is, doesn't matter. So I see a pattern here that's going to really help us now. So I see how to generalize this pattern to n balls, and that's sort of the key. We want to basically observe this pattern and see how we can generate a formula for the probability of n balls. So we can see that now. It looks like we basically take n plus 1, subtract the threshold value, 3/5 of n, multiply that by 2, divide that by the total number of balls, n plus 1, and now we're going to try to solve for n such that it's just less than 321 over 400. So it looks like we're trying to find the least value of n which satisfies this inequality. And that looks pretty encouraging now. I think we know how to do this. So let's cross multiply in the usual fashion. So 400 times 2 times all of that is 800 times n minus 3n, that's 2/5 n. And there's a plus 1. And we want that to be less than 321 times n plus 1. Plus 321, and let's see, multiply that out. 320n, 800, 321n plus 321. Okay, so now I see why they chose 321 here. That kind of makes this work out pretty easily now. So we can move the 320n to the other side, this to this side, and what does that give us? That gives us 4 79 is less than n. And okay, we see that the least value of n which can satisfy this is n is equal to 480. And the sum of digits of 4 and 8 is 12. And that is choice A. Pretty lengthy problem, but I find it always helpful to look at some case examples and try to draw some figures wherever possible. And that helps me a lot. So anyway, hope that helped, and take care. Bye-bye.